Now it's a real pleasure to introduce Ken de Cooman. So Ken is the co-founder and director of BC Materials. And BC Materials transform excavated earth from urban construction sites into circular local clay building materials, such as compressed earth bricks, clay plasters, and rammed earth. So these materials are CO2 neutral, provide a healthy indoor climate, and are characterised by a highly energy efficient and local production process. And Ken, you weren't here earlier on when I said that I went on a personal pilgrimage to Luma. So it's really, really wonderful to have you here with us today. And you're a fantastic demonstration of what's happening elsewhere outside the UK. And you're really managing to navigate those barriers that we're getting stuck on. So yeah, it's a real pleasure. Thank you.
All right, thanks. It's super nice to be here. It's amazing to see how one material can go all directions. And I think that's also a bit what we do with BC, and why I'm also so happy to be here today is that we use the material to touch on a lot of different subjects. That's what I'm going to show a bit today. So I am Ken, I'm from BC, which is an abbreviation for Brussels Cooperation. So we're based in Brussels, Belgium, of course. And in fact, BC operates through 3 legal entities. And I think that shows already a bit how hybrid it is, how we have to organize our practice in order to do the things that we think are necessary in the construction sector. So there's a BC Architects, an architectural company. There's BC Studies, which is a non-profit. And there's BC Materials, which is a material development and a material production cooperative. And so in terms of materials, we try to summarize it also for ourselves, but also for communication in 3 ways. So we have everything that is geosourced, which is unprocessed from under the soil under our feet, which can be nature stone and earth. We had this exhibition where we showed this in a room. There's also biosourced. We work a lot with fibers, as well as wood. This is the project in the south of France, Atelier Luma, which I'm going to present later. As a third category of materials, which we also work with, is urban sourced. So we see the Anthropocene, we see the sediments of our urban metabolism. We also see it as resources. We have to take care that it's not polluted. We have to be careful about it and so on. However, there are also resources that we can work with. We also heard it today in other projects, amongst which the one from Tucky Design. So geo, bio, and urban sourced materials is what we work with. But it's also very important that these materials are not only considered as a material development, but it's bigger than that. It's about people learning together. So actually what we do is we create learning environments for ourselves as well as for students. We teach at some universities in Germany and Belgium. Where this room then was made by students where they had developed and get to know the material and the reflection and the impact of that material in this 4th room, let's say, educational. So for us, materials are a window to look at everything that society has to offer in terms of governance, organization, relation, human, nature, and so on. So one project where we were involved as architects and bespoke material developers and producers is the Atelier Luma project. Atelier Luma is an organization which researches biooriginal materials in the south of France, and it's part of the Luma Foundation. And it's a little bit funny because the Luma Foundation owns this park. It's a big arts foundation. And so on the one end of the park, we have like a Frank Gehry with titanium facade plates. And then on the whole other end of the park, the latest building, so this is chronologically the first building, then renovation of this, and then we did the renovation of this warehouse here. It was a total different approach on the other extreme end of how to deal with materials and constructive systems. And so Atelier Luma is based here. It's a little bit off screen in this warehouse. And they do bioregional research, which means that they look into local resources of the bioregional kind and what they can do with it. For example, here sunflower stem and sunflower pit, which is being thermocompressed into panels. That's a research of Atelier Luma. Also salt, it's a region with salt production. How can this be made into panels, for example? Here is algae farming in the south of France, how to transform that into bioplastics. And so let's say Atelier Luma is doing this kind of design research where they focus on the object scale, let's say. And so we were entered into this project together with the UK office, Assemble, which we also saw passing by today. And so you see it's all networked, we're all linked, we all work together towards the same goals. And so together with Assemble, we kind of took on this project in order to see, okay, how can we do this, but then on the construction level, not from a design or a product design, but really to the scale of a construction for the headquarters, the infrastructure for Atelier Luma. And so we also did a bioregional mapping, just the audit, like we heard from Ben also. The audit of what resources are there available. So, for example, here this is a beautiful quarry, a very soft limestone that is used for ornamental objects such as railings and stuff like that. And so they have a lot of cutting waste, which historically was being used into plasters, but since the 70s got a little bit neglected because it's not industrial enough. But in fact, it's a very beautiful resource. We really did a lot with it in this project. I will show you later. But also washed sand, a big quarry, open-air quarry for the concrete industry, where they wash sand and they use the sand for the concrete. But whatever is washed, the silts and the clays, in fact, is not even flocculated. It's just left in a pond south of France. You have good weather there, so the sun can do the work, and is just left to dry, which also creates this very beautiful color clay-silt mixture that we also used in the project. But also urban sourced, also the building was there. So again, the same story. We heard it a little bit today also. Checking which tiles are good, cleaning them and reusing them. And the tiles which were not good anymore, crushing them into gravels that we then use in certain materials in the project. So there's lots more of materials that will pop up later on. We also worked with sunflower stem and pith in some other applications, and rice straw that we will see. Also, just from the recycling center, demolished buildings. This is like, we call it mixed in France. So it's actually not a recycled concrete, but everything else of mineral waste. And so what we see here in that region, beautiful gravel. Why? Because a lot of the buildings are nature stone. And a lot of the old buildings are nature stone. When they're unfortunately demolished, they end up as a gravel here. So it's actually really high quality recycled mixed material. So yeah, this is the bioregional mapping. That is a start and a start for us to see what materials are there and what can we do with it. And we start the material development directly with the architecture. So you see here the first model and the first prototypes at the same time, because we want to discover the materials and see how this can influence the design process. So there's 3 big spaces in this warehouse. This is the main, the biggest space, let's say. It was left kind of untouched, just a bit of renovation, but it's a kind of a public event space. And then we have here the labs, more of the offices and the quiet spaces, the more scientific spaces for Atelier Luma. And then here we have the more loud workshops where we can have machines for cutting wood, panel, the thermopress was there, and so on. Into one building. And so each of these zones had a bit of a different focus. The workshop zone, the long zone, was mainly oriented towards, let's say, biosourced materials, where we sourced local wood. We painted it with a mix of local algae and linseed oil as a kind of protector plus paint. And then also the sunflower pits and stems, which were used together with rice straw fibers into compressed panels. We have to wait a little bit. That were used as a wall cladding in the project. Yeah, here we can see the wall cladding, and you see this kind of popcorn-like sunflower shredded pit, which is a very interesting material that we also used into the project later on. Rice straw bales that we used in the project as an inside insulation in the warehouse in a wood structure, as well as a load-bearing structure at some point. So pre-compressed load-bearing straw bales in this project. Together with non-load-bearing straw bales, there was a mix because the project was set up as a school for ourselves, but also for all of the craftsmen, all of the contractors who were on the site and working with these materials. And then also here, yeah, on this picture, maybe a little bit more difficult to see. Yeah, we have here the rice straw insulation covered with acoustical earth plaster, acoustical absorption. So we used lots of fibers in this plaster, together with the sunflower pith, which actually, when you shred it, it's like this popcorn nodules, which are a little bit elastic. And so inside the plaster, this creates for like absorption of sound waves, which was tested in the laboratory in Lyon, where we had an alpha absorption coefficient of 0.7, which is really good, which is actually the same as the polyurethane foam panels that you can buy on the market. And so, yeah, in this project, we had to also convince the acoustical engineer to use this material. But the lab testing is part of the convincing process that that these materials can really do the trick. And then also base plaster on top of the straw bale walls. That that we can see here, the color, the orange color of the washed clay here, and then the top layer we did white, a little bit for aesthetics, where we used a lot of the fine, very fine silt sand from the quarry waste cuttings of that super white limestone. And so all of these materials, they generate a beautiful space. I'm going a little bit too fast. A beautiful space that really is, is very soft in its tactility and its appearance. It's also not really controlled by a designer or an architect of how it will look. We want this color, we want that color. It's more like you prototype and you try, and along as you go, while you're designing the spaces, you find stuff, you discover stuff in team together with other people, craftsmen who come to try and so on, but the same process as we saw in other projects today also. And it's this other type of design. Remember Frank Gehry that scribbles on a paper and says, this has to be it. And no matter what detail you have to invent, no matter what material you have to use, it needs to be this. On the other hand of the park, you have this kind of very found beauty, where you work with what the materials give you, what the materials make possible, and you just make a composition of what you find. The other space is more mineral. We used rammed earth and compressed earth blocks there. Super beautiful white. It's also found. we didn't look for white stuff, but we just found a good white clay, which is not totally white, not totally kaolinitic. Actually, kind of bentonite rich, grayish, whitish, beigeish clay. We mixed it with a very white fine sand and from the quarry waste, and then we get this type of white materials, non-stabilized rammed earth and lime stabilized earth blocks. Because of risk assessment of stability engineers in the project, sometimes you cannot win all battles. And so, yeah, these were also tested in laboratory on different kinds of tests, drying shrinkage, and so on, to be able to be implemented in the project, as you see in this picture. And here we see the load-bearing straw bales on this side, and past the window on here, let's say, a wall, and then on the other side it rests on the rammed earth, which is then a G+2 story combined rammed earth and compressed earth blocks structure. Also beautiful and also a little bit of a discovery by just playing around was the roof tiles that we couldn't put back on the roof. We played with them. We crushed them into gravels, made a nice outside lime plaster with very thick blocks of these roof tiles, let's say. And then also we cut them longitudinally and we put them in a terrazzo floor, and it became like a beautiful drawing. First here the external render that on the picture doesn't show so well because of the resolution, but like there's a kind of texture about it that is really linking up with the roof. And then here on the inside, this is while it's being installed, these kind of drawings in the lime terrazzo that you see here on the floor. Again, the resolution doesn't show it very well, but it's like this kind of playful found thingies of the roof tiles coming back in a different form in the floor. So in the end, the project is really soft. The colors are very soft. The acoustics are soft. The touch is soft. So everybody who goes there, is really impacted by just the type of materials that are being used. It really does something. It really changes the relation between our other skin than our own skin, let's say, and the building skin around us. Yeah, so this is a project, you cannot imagine how much people passed by, how much different contractors, craftsmen to produce these materials on site, to install them, people who are experts in nature stone, people who are experts in straw bales, people who are experts in nothing but became experts afterwards. It's like, really like a kind of a learning school setup around this project, and that's how we try to work, in fact, to always keep on taking next steps with every project that we do, so that everybody can learn and so that we can change a bit our ways. So final pictures. Yeah, and these bespoke projects, these kind of made to measure, where we put a lot of effort in and a lot of our ideas, and a lot of our tries, a lot of our learnings. In fact, when we learn stuff out of there, we kind of implement it into a standard product range, which we produce with BC Materials as a material production company. And so this kind of philosophy of reusing what is local, we have set it up in a more structural way in Belgium, where BC Materials produces earth building materials made from excavated earth. Our first big development that we could do for the product range was in fact the Metro 3 works in Brussels, so very similar to the HS2 lines in London. These are the projects where you can attach yourself onto and really generate the necessary funding, the necessary attention to really develop these projects. So I will show later our masonry blocks, which come from this Metro 3 research. Yeah, the numbers in Belgium, 37 million tons per year, of which around 40% is non-disturbed, purely geological, non-polluted, and non-reused. So that's around 14 or 16 million tons per year that is really, really being thrown away. The situation in Belgium is that once an excavated earth leaves the construction site, it's officially considered as a waste. So with BC Materials, we are a waste transformation company. It's in our environmental permit. We can transform this specific type of waste into building materials. So we operate on two places in the chain. In Belgium, earths are being extracted and reused on the site or transported to a temporary storage center that gathers different kinds of earths. And from there, they try to find solutions for landscaping or landfilling, whatever is possible. And so, in fact, sometimes we operate close to the construction site with mobile machinery, but it's expensive. Doesn't happen so lot, but it happens. Most of the time, we let trucks from the temporary storage center, sometimes directly from the construction site, but mostly from the storage center. We let trucks come to our place, and we have sorted geological resources, different earths, that we then combine to make our mixes for our earth building materials. So that's the image that you saw before also, the fact that Earth is circular. And like, for us, Earth is circular in origin. It's considered as a waste. It's a secondary resource, but in fact you can use it. But it's also circular in destiny. At the end of the life cycle, Earth does not chemically alter its composition, and so you can keep on reusing it, as Roland explained so good before me. I will not repeat, we all know it in the meantime. We all know that also, earth, healthy, bio-based, beautiful, and so on. So how do we operate? This is a section of Brussels. We source from Flanders also, but actually a lot from Brussels. This is around the Seine River Valley. And so we have lots of alluvial clays here. And this is high Brussels. These are dunes, old dunes, when the sea and the marshes still came just until Brussels. And so this is actually a high quality sand. And here we have loams and clays, and the purple one is actually a deposited clay layer from a little bit older times. And so we depending on the construction site, we touch on different layers. For example, this is the Brusselian sand from high Brussels, historically used as a mortar sand. There were different quarries all over high Brussels. Now they're closed with urbanization. Now it's a square or it's a city hall that is on top of it. But like in the 19th century and before, there were these small quarries operating to make mortar sand. And what this today, when this leaves the construction site, it's legally considered as a waste. While it is non-polluted, non-disturbed, like quarry material, in fact. So that's what we do. We kind of again consider this as the material with the value that it has, just like the old days. Another construction site in Brussels, in Low Brussels, with a deeper layer. We touch here on the clay layer. This is the Ypresian clay, because the clay layer comes above, amongst other places, in Ypres in Belgium. But actually, Wienerberger, the multinational, I don't know if it's famous in UK also, but in Europe, they have lots of factories for baked brick production, where the layer comes above this, like closer to the surface, around Boom. They excavate the exact same clay in a quarry, primary resource for a factory, while in fact, this is again here in the construction site, a waste once it leaves the construction site. So Flanders and Brussels has a lot of fine material. So we need to, for some techniques, we need to supplement it with coarser material. And so for this, we use urban mineral waste. As one example is here the recycled concrete of demolishing of buildings. We use also other urban mineral wastes. Depending on the product that we do, we use it as a sand replacer in our products. And like this, we bring a brand on the market which is called Leem. So this is for plastering. This is for blocks of masonry, and then this is for the granulates of rammed earth. So the categories like of the different materials. Leem means loam in our language, and the accents are because we also have a French market, and yeah, for the pronunciation, it's good that there are accents. We have earth plaster, we have a clay finish, we have clay paint, and all the accessories that go with it. You see, we have 4 colors. That's what the earth gives us in Belgium. We have rammed earth mixes. And we have masonry blocks. And so it's these blocks that we developed in the framework of the Metro 3 excavations of Brussels, where the Metro line nicely went into different geological layers, where we could then make our recipe from for these blocks. This is the website, leem.works, where there's a typical website for a building materials producer, where you can find all information, technical sheets, technical guides, and so on. And this is our production model. So instead of doing everything ourselves, of course, we did everything ourselves when we started. Our first year was 75 tons of transformation. Last year was 4,000 tons of transformation. So nowadays we don't do everything ourselves anymore. Everything is prepared at our premises, but for some products, for example, the blocks, we work together with industrial partners because they have invested millions of euros in very good machinery, and it's a model that we do not want to do ourselves. We don't want to invest millions of euros in machinery, because then a certain kind of pressure comes on us for return on investment, and we want to be more agile than that. So, and also running a factory is very different than developing materials, let's say, or working working on a smaller scale. So we try to make smart partnerships with partners and try to not invent the wheel, but work with these typical industries. For example, baked brick industry, concrete block industry. Where we actually replace, instead of concrete in the machinery, we insert our mixes that we prepared into the machinery. It's also a nice idea that, in fact, you're not adding again a factory and making other factories obsolete, but in fact you replace fossil fuel intensive materials within existing production infrastructure. So we did a whole block research. I remember also having an online meeting with Roland about HG Matthews. We did it for all of Europe, a research of what type of blocks exist, what is the best block for our construction culture to make, what size, what technique, what has to be the performance of it, and so on. And in the end, we chose for 2 blocks. This is the first block, a molded block in the facade brick industry. So this is like molding with a machine at a rate of 80,000 blocks per day. So really, like high capacity machinery. And normally they're being fired, but we can here insert our mixes and take them out just before firing and put them on a pallet. So that's one production facility that we do. And another one is compressed air blocks. So it's a whole different material, a whole different product because of the different recipe with different characteristics. And that here we do in a vibro compaction facility, a concrete block factory, which we are lucky enough in Belgium that we still have also family businesses. This is Freddy, the owner and the starter of the factory, and these are his two sons. And Freddy doesn't work anymore, but with the 2 sons, they operate the whole factory, which is really like super efficiently organized. It's crazy. And as an anecdote, Freddy, the owner, bonded a bit with us because he saw in us what he used to be in the 60s, 70s when he started. He had this very small machine, and he invested in a time when the economy was you could still build up something, which is now much more difficult. And so he bonded like this with us and was keen to collaborate. And we see here Rodrigo from TerraBlock from Switzerland. That's another compressed air block producer. He had experience with vibro compaction machines, and so we are here to exchange and help each other. So I think that's also important. The learning is open, and we help each other. There's no secrets. Like we exchange so that we can move on faster, because our goal is not the most profit for ourselves. Our goal is the most impact in alliances in our construction sector. some images of the vibrocompaction facility. It goes in this kind of trains. We call it trains here above each other, and then the train goes automatically to a drying chamber. And so we keep on doing these innovations. We're going to launch a material which is a port earthcrete. And again, it's a bit the same philosophy. We work with existing machinery. We try to make it, simple with the machines that today, the craftsmen of today know. It's a different kind of craftsman, I know. It's not the hand craftsman, which also exists, and that's very good. But there's also, craftsmen of people who know how to handle machines and things like that. And so we also try to work with these type of craftsmen in order to shift from what they know as concrete to now to pour earth instead of a concrete slab. And it's a bit of our approach that we try to do. So this product has been tested on 10 construction sites, and we will launch it in 2026 as another product next to the ones that you saw already. Yeah, so that's a bit the story of this hybrid practice. At the same time, it goes very wide. It's very networked, a lot of collaborations. And at the other hand, it also goes deep into material development. I was very interestingly watching the presentation of the person before me, because that's also the kind of stuff that we also have to do. We don't have so much time for so much mixes. I think our budgets are a bit smaller, but it's similar what we do. We test, we try and we test and we learn, and we try to get principles out of certain material mixes and try to see what is it good for. So it's quite a similar project. It's quite a similar approach, I have to say. Yeah. If you want some more information, that's the general website for BC Architect Studies Materials, from which you can go to the websites, or lane.works for the earth building materials. If there's any questions, I think we still have some time. Yeah. All right. Thanks.
No worries. I don't know if you'll know, but I'm just wondering, a lot of other European countries seem to be so much further ahead than us with this. And I don't know if you have any insight as to why that is. It feels like we're sort of 10 years behind on it. It's really impressive. Like, all your work's amazing. So just insight on that.
I don't know totally the answer, but I have some ideas. So I'm not claiming to know any truth. But sometimes we talk about it with some people who are also based in the UK. With Assemble, we have this kind of conversations with the people from Carmody Groark also that we work together with. And so apparently it might have to do. So we get funding from the start. From the start, we get funding, in fact, and so there's small fundings when you're really at the start, but then the opportunities for funding, they can grow as you go. I have to say, we could exist without funding. We have every year we have profit, let's say, that we then decide what to do with it and so on. But to keep on investing in new materials and not just stick with what you know. For that, we don't have the extra space. For that, the profit is too small. And so, I also told it to Ben just before. Like, we have a funding rate per year, and it grows with our activities of around 20%. And that 20% is really good to invest sometimes in machinery, but also to invest in new knowledge, into trying stuff out which does not fit in an economic model yet. For example, this floor, the development of this floor was funded. The development of the blocks with the Metro 3 line was funded by the Brussels region. And so I think how I see it, or what I understood in the UK, is that in order to have funding, you need to be already a bigger consortium, bigger actors, more economically established actors. And I think in Europe, at least in Belgium, there's the possibility to have also funding for this, for the starters a little bit, but also especially for the middle size, the ones who have proven that, you know, they have a good idea which is validated, but now they need to invest, you know, to be able to do it on a further level, let's say. And I don't know, maybe you can contradict me, but that's a bit what came out of it, those conversations. It's like funding is really important for us, and in the UK that it's like mostly available for bigger structures.
Yeah, we've never had any core funding.
Yeah.
This is so weird. This kind of continues on from that. I just was wondering about the. There was somebody earlier that was saying, one of the speakers was saying about waste transfer, and I wondered whether do you also get funding for that to be part of that process of transferring waste? Whereas here it seems like that would be something that you have to pay for as a license. So, you know, yeah. I just wondered if you could speak about that.
Yeah. So we're still a little bit too small to get paid to take earth, but it's certainly one of the possibilities. I know that when it's possible for us to in a guaranteed way take 1,000 tons, starting from 1,000, maybe 2,000 tons of a certain earth, that we can guarantee take it in 1 year, then we will start to receive money for taking that earth, because then we're on a level that solves the problem of these big recycling centers that have limited space and that need to get their earth out of the way. And so we had conversations already, but because we're now too small, we get the earth cheap. We only have to pay transport, or we pay €3 per ton, which is really cheap for a resource, because it's still too small. They still have too much work with us to organize it, so it still costs them more than just bringing it to a landfill. So there's a balance to be struck. I hope that we get there soon, because it will help our business model, because the materials are still more expensive. There's still a big green premium with regards to the fossil fuel intensive upscaled materials.
Ken, one of your slides, you showed the extraction of material and then it's going to your different sites and your different production. And you had this one little thing where you said, this is a place where material gets stockpiled. Can you just talk a little bit about that?
Yeah, so in Belgium, most of the earths, they cannot directly go to a landfill. Because the timing needs to be right to go there. Sometimes the landfill is just too far. It's mostly old quarries that are being filled up, and sometimes it's too far to go there. And so, but the contractor needs to get the earth from the construction site, because things need to go on. And so the government has organized a system where there are temporary storage centers where earths arrive, and they have a bit more time to find a solution for it, of how to get rid of it. And yeah, Flanders is super urbanized. It's the most urbanized zone of Europe. So we really have issues of disposing of it. We bring it to neighboring countries. We make mountains. There's a mountain in Ghent next to the highway, if you're ever in Ghent. Like quite a big mountain of earth, yeah, because it's really problematic. And so, but this really helps, because for us, that's almost our one-stop shop where we can go to, and we have a good relationship. And Belgium has a long history of recognizing geological layers linked to the brick industry. So before, we only used our excavated earths for the big brick industry, but currently, because people want fancy colors, the Belgian material only bakes red or yellow, and so with fancy colors, this activity became much lower than before. It's like maybe 10% of their resources that they use, and the rest comes from Germany, Ukraine, and so on. But Ukraine now, not with the war, but before, and so the recycling centers. And so there's a habit of recognizing earths and putting them aside according to their geological origin, and it goes quite far. And for us, that's fantastic because that's a work that we then don't have to do anymore. And so it's really the guys with their crane on the side. They can see what type of earth is what, and they have their little field tests with them if they're not sure, especially for the carbonate content, because that's what defines if it bakes yellow or red. Then they have their little bottle for the lime acid test, and then they know, and so there's a whole culture around it historically that we can really make use of. And so that's different with Cycleterre in Paris. They're now bankrupt, but Cycleterre had to set up the whole supply chain, had to really work with the earth workers to really set aside this specific earth, and it was super difficult for them to organize this because it's not in the culture yet. So we were a bit lucky that we could do that. And in Terrablock in Switzerland, they have they don't have an issue neither because every earth it's glacier earth, so they have everything from clay to gravels. And so the only thing that they need to do is, when they find a construction site, they need to mill it to the right granulometry, and they can always use the earth. So every locality, also in the UK, you have to find your own logic of how to deal with your earths of your region, how it's organized with legislation, what is possible and what not, and you have to kind of find your way in to attach on the supply chain in order to reuse this earths. So it's never twice the same, I think.